Now the next topic that we are just dealing with is that sensitivity topic. That is the first topic before the power and effect. So now let's get back to the points. What are the important point that we are just. So what is sensitivity? Sensitivity is the ability of a governor to change the output load and change the power supply. So it is main work is to observe the output load change and then change the power supply. So sensitivity is reciprocal of one by stability. So how much the sensitivity is more, the more the sensitivity, the less the stability. So now for the case one, the governor is that independent. So two case then there will there can be two cases, and it's the governor's independent mechanism and not connected with any parameter. That is case the sleep displacement will be large corresponding to the fractional change in speed. So sleep displacement will be large, we can see, and the fractional sleep displacement is that government is independent of mechanism. Then in the coefficient of sensitivity, what will we get? That is the mean speed by range of speed. So that is the mean speed by range of speed. That is the W max plus W minimum 2 into W max minus W max range. And then the second case is that when the governor is connected with any of the prime movers. So what will be there in this situation that the governor is to minimize the speed fluctuation. So what will be work in that case? That will be the reduce the speed fluctuation and what the load to and change from the full load to no load condition. So any load there be, we have to change and to minimize the speed fluctuation. So then coefficient of sensitiveness is the range of speed by mean speed. So it will be the opposite to the previous one, that is the when no load is connected. So that is 2 into omega max minus omega min, that is the range by and omega, and the mean speed by omega max plus omega minimum by 2, that is the mean. And sensitivity should not be 0, then should not be less. That is the important point. Sensitivity should not be 0, that is main point. And there is two cases, there omega max plus omega minimum by 2 into omega max minus 2. So here it is the negative and here it is the positive. So what will happen here, the denominator is small, then the upper side will be greater, and here the denominator is greater than upper side small. So small sensitivitiness, so the sensitivitiness for this case is small, and we want that. So that is why when connected with prime number it is being selected. Then hunting of a governor is that it is for the isochronous awareness. So what is isochronous? That is omega minimum and omega maximum and omega, they are just constant. So what will happen when it will in this any position, what will happen that the random violet oscillation will be heard, because there will not any change. So what will happen, any there will be sensitivity is infinite. So thereafter there can be used in any prime mover. Why the sensitivity is infinite when it is independent and zero when it is prime mover? So why? So that's why it will just gonna abruptly oscillate. So that's why it is not selected. Then government comparison we are just doing. So we are just taking a picture. So what you can see, there is a two governor, that is FC2 centrifugal force, FC1. Then it is the governor one, this is governor one. So it is the at the lower portion and it is the equilibrium one. So there is a two force, that omega one and omega two are different, but here omega two and omega two. So for the same case, for the same change, what you can see, that the governor one, that the governor two is the less fluctuation, governor two is more fluctuation. So in the for the same here in the same graph also it has been shown that for the governor two the fluctuation is more than the governor. So this case the fluctuation is more and this case is more. So why that the governor two will be more stable, the governor two will be more stable than one. So it is more preferable. Then that the coefficient of insensitivity, that is second. So effect of the friction. So due to friction, that is the thing that we can see here. That is that there is no friction between the sleeve and skin depth. But when the friction is there, so what will happen? That is the omega, that is the force. Angular speed we are just putting it, but 30, 29, 28, we are just putting some speed. But maybe there is an insensitiveness, so till 28 it will not gonna move. There will be friction, that's why it is not gonna move to the stopper position, the TTC or NPDC, like in 30 in 30. So in this case you can understand that the force we are just applying 10 Newton and 5 radian per second change in the speed is to overcome. So till 5 radian change in plus and minus side, there will not going to be any change. So here that is the thing you can see, that 31, 32, 33, 31, 33, till this point we are not going to see any change. So what we are doing, that is the mg, and we're just minus subtracting it, and then we can see that till this point there will not change. In the lower side also that is the same, that is the Gardner insensitiveness. So this is being shown is here, till that point there will be no governor, there will be no change, and all the speed changing but radius is not changing. So what will happen, there will be speed that will change, but the radius will not gonna change. The governor till this 25 and 35 now, there will be no change in the radius. That is a simple thing that you can see. So change in speed is v w minus w1 is w1 minus w2. That is the w1 and w2. So w minus w1 to till the last point 35 we are taking. So from there we are just saying that change in speed, that is omega 1 plus omega 2 by 2. Coefficient of insensitiveness is ci equal to w1 minus w2 upon w. And from there we will get w1 minus w2 by 3. That is the simple thing you can see. Speed is at which there is no friction between the sleeve and spindle, that is the omega. Omega 1 speed at which the sleeve is about to move upward. It is upward, and for omega it is the same thing, but it's going to move downward. There mg minus a and here mg plus a. So it will be mg plus a. We're just making a mistake. So mg plus a, and in this case mg minus a, because you have to take this much more amount. Friction always makes a governor insensitive. So that is the main point here. With the friction always makes a governor insensitive.